Alright, so I know some people are traveling this week, so there may not be that many people, but we can get started. So I've started the recording, and let me just make sure this is working. Alright, let's get started. So today we'll be covering lists and iterators. What this means are, these are arrays and loops basically. So we'll be covering how to store data using arrays, how we can traverse arrays using loops, and what exactly that means for us, and how we'll be able to level up and improve our programs using this. And we'll also have a type along, which will be a little different today. I will let you guys do some of the work, so that I'm not spoon feeding you through the entire process. So that will allow you to gain more practice with this. Alright, next slide. Arrays. So arrays are data structures, data structures are different ways of storing data. Arrays are a specific way which you can store multiple elements of data. This means you can store integers, doubles, strings, but not only one of them, but multiple of those. So you can see here we have the array structure defined with 6 elements, 6 integers to be more specific, and we're storing those using this array. So we're able to group all of these into one single data structure, and we can transport this throughout our program and modify it to our extent. Which is why arrays are really useful, because instead of having to declare this many variables, 6 variables, you can simply just store these many variables into one single variable and then transport that around and use it however you want. Arrays are treated as objects like you see here, like strings. We covered strings last time and how strings are treated as objects and how we would use the object map to actually find the relationships between different strings and to which strings point to which objects in memory. Because there's a difference between the reference and the object in memory, remember? The reference is the one pointing to the object in memory. To declare and initialize an array, which is the second point right here, we can use this format, this specific format for arrays specifically. And you can see here that we need to define a data type first, and then we have these square brackets right here. Along with the name, variable name is always necessary. And then we use the equals operator, the assigning operator, which means that this will be evaluated. So we have the new operator here once more, because arrays are treated like objects, so we use new. And then we say data type with the square brackets again, and then we say the size inside of those square brackets. This size cannot be changed, so whatever you set here will be the size of that array permanently throughout the entire duration that that variable exists. So the example given right here is the integer array. So we have an integer array called numbers that has 5 elements right here. One other way that you could think about this, and I just thought about this recently, is that you can think of this itself as like a data type, like an int array. Like these brackets could symbolize the array itself, but that's not really thought of in Java, but that's one other way you could think about it. Anyways, we also, I guess this is an example I put here, make a string array with length 5. The way you would do this is just saying the same thing as this, but you would put string here, and remember it's still capital, because in arrays you can store objects as well as these primitive data types, and then you would call it whatever you want, equals new string, and then square brackets, and then 5 as we see here. So it's the same thing with objects and primitive data types. It's just, the question is just of what you want to store in the data, or what you want to store in the array rather. how we can put the values in an array are shown here. So when you first initialize arrays, we saw this, but this does not initialize any values. In fact, this sets all of the values in this array to 0. So when you look at this data structure, what you would see is a 0 here, 0 here, 0 here. All of these values would be 0, and you would only see 5 of these. But if you wanted to initialize the array itself with values at the start, if you wanted to say, hey, when I declare and initialize this array, I want to put these numbers inside. To do that, you would say int array numbers would equal to whatever you have here inside of these curly brackets. And then you would put your values inside here, and that would be the value stored in the array itself. Some other ways that you can initialize values in the array are using this bracket notation. This means that at this position, we will set it to this value, and we can access positions of arrays using these things called indices. And we'll be covering this on the next slide, or the one after that. But indices are a way to essentially define positions in your arrays and know at what point in the array you are looking at. So here you can see that we're looking at position 2, or index 2 rather. Now it says, now what are the values in the array after the top statement executes? So let's see, we have first an array of 4 elements that's being made 1, 2, 3, 4. So you would see 1, 2, 3, 4 for only 4 of these elements. And then we say at position 2, I want to change it to 4. So let's go back and see where position 2 is. Position 2 seems to be right here because it's labeled array indexes. So position 2 is right here, so we would change the third element in this 4 element array to 4 right here. So it would be 1, 2, 4, 4. That would be the values after we run this statement. Now here we have a different example. We're using like the string data type, the string class as a data type, and we're storing these different strings as values in the array. So we have mad, sad, and happy as feelings. The data type in this case would be strings because that's what we define first, and then the length would be 3 because we have 3 elements. How do you find the length of the array in code? That's what it says right here. So we can use this dot notation, and then we would say dot length like this. The reason why we don't have parentheses here is because this is not a method. That's like pretty important to know. This is not a method because we don't see those parentheses here. In fact, this is what you call a property of the array itself. So that's not something that you regularly see in Java, but that's very crucial for arrays because some people put parentheses here and they wonder why their code doesn't run, but it's because length is not a method, length is a property. In this case, it would return 3 because we have 3 elements right here. This returns, what does that mean? Well, we covered this a bit last time. It means that the value of whatever this expression here is, that will be 3. So returns is like, that's like the value essentially of that expression. When we say like what does a method return, we ask like what will be the value that the method will give back once it's called to the program. Alright, let's move on. So arrays are immutable in terms of length, but the elements can be changed. This means that when we go back to the first slide, this means that whenever you make this array with a certain amount of elements, so here we have 6 elements, that cannot be changed like we saw earlier. This means that this array will always have 6 elements in memory, and it will always point to those 6 elements. But however, you can change what each element specifically is. So we saw this with the indexing syntax. We can change this 10 to like a 600, for example, or a 4. That we can entirely change. One more thing is that we can only change it to the same data type of what we see here. We cannot change this 10 to like say happy or a 10.0, because the array is defined with that data type and it will always have that data type. However, there is like a small like quirk, I guess. So there's this thing in Java called type promotion, in which you can put smaller data types into larger data types. This means that like when at the beginning when we saw those different primitive data types and how they store different amounts of memory, all of the smaller data types, you could put those into the larger data types. Like for example, because a int stores less data than a double, we can say double like number equals 5, for example. Like I'm declaring and initializing an array. So if we said double number equals 5 as an integer, that would be perfectly acceptable because of this thing called type promotion. I think the same thing applies to arrays. So if you had a double array, which means that it's all decimals, you could say like array index of the array. If you want to change an element at some point in the array, like for example 2, you can say array, and then using this notation, array and then index at 2 would be equal to like 10, and say we wanted to do that for a double array, that would be like perfectly acceptable. So yeah, that's just one important like thing to know about arrays and variables in general, so it's good to know. Let's go back. So default values when no values are assigned are typical default values for data types. This means that we didn't really cover this when we covered data types, but whenever you make an array, it will have this specific data type. So let's say we were making an array of all integers, then that means that all of these would be evaluated, or not evaluated, but rather set to 0 at this point. So there's that. For other values, it would be 0.0 for double, for all the other decimal values as well, like float. And then for strings, it would be null because strings are an object. The default values for objects are null by default. But if you try to access the array index at that point, or the array element at that point, at that index, then you would get a null pointer exception because you're trying to access an object that points to null. And then for booleans, it would be false because the default value for booleans is false. And remember, booleans can only be true or false, which means that it's stored as 1 bit in data, because 1 bit is either a 0 or 1, which represents the true or false. So let's do some practice. So I put one array here called letters, and it's this data type. This is a character data type, which means that it only has 1 letter. And I actually made a mistake here. All of these should be single quotes, because in Java, when you're making character data types, you would only use a single quote like this, for example. So yeah, all of these should be like this. In this case, all of these are 1 character string, so I can just change this to string, and then that would technically still be correct. Anyways, let's see how this indexing exactly works.
Wait, excuse me?
Yeah.
So, you could, anything, integer string and then put a bracket, and it'll be an array.
Yeah, you could do that. You can do that with any object in Java.
And is that brackets, required?
Yeah, it's required for arrays, because otherwise it would just be a regular variable, right?
Oh, okay. Just asking. Alright.
Yeah, it is. So basically a double is the same thing as a float. Yeah, doubles have more range than floats, and longs have more range than integers because of the amount of data that they allocate. So yeah, that's correct. So alright, let's go back to array indexing. I think we should, let me check if there's a slide on this. I thought I put one. Wait, let me check the chat. Yeah, I think it's 8 bytes for long. I'm not entirely sure. Let me just double check. 8. Sorry, real quick. Let me just check how many. A long has 8 bytes, and then a double has 8 bytes as well. And then int has 4, and a float has 4. Yeah, so that's entirely correct. Yeah, it was in the first or the second slideshow. So yeah, you can go back to that if you don't remember. Anyways, let's go on to this. So when we're talking about array indexing, we're going to need to know how to find what value is at that index. So in Java, when you have arrays, like I'll just draw it like this. Wait. So when you have arrays like 1, 2, 3, 4, like that, the way that we can access the position is by numbers. So we have a specific position or a specific number that is related to each position, but it doesn't start from like 1, 2, 3, 4, right? It's not like first position, second position, third position. In fact, it starts from 0, because that's like the standard convention, I guess, for Java and CS in general. But it will start from 0. So this is actually the 0th position. And then this is first, and then this is number 2, and then this is number 3. So even though the length of the array is 4, the maximum index that we can access is actually 3. So that's one important thing to keep in mind. Alright, let's look at these ones then. So if we're finding the value of letters index of 3, we just covered like this as an example, but letters index of 3, remember that would be 0, 1, 2, 3. That would be G. So this would return the string G. That would be the value of this expression right here. Now, I think this is, this is what we'll cover later. But letters.length will be how many elements we have right here. So we have 9 elements. So 3, 6, 9. Letters, and then this position, so we have to calculate this. Now remember, arithmetic in Java, it's going to follow like the PEMDAS rule. PEMDAS. I don't know if you guys remember that, but that's how we're going to evaluate that expression. I don't know why this is not allowing me to clear, but I think we can do this in our head. So first thing, multiplication, 4 times -1, that's -4. 3 minus -4, that's 7. And then 7 plus 2 is 9. So we're accessing whatever the 9th index is. Not the 9th element, but the 9th index. What is the value at the 9th index? Well, we already saw that we have 9 elements, right? That means our maximum index is 8, which means that this is actually going to give us this array index out of bounds exception. I mean, it's in the speaker notes, but yeah. So we're going to get that kind of exception that's going to be returned by this expression right here. And now the same thing with this, because we know that the length of the array is actually 9, we're not going to be able to access that index, which means that this is also going to return the same array index out of bounds exception. So yeah, whenever you see this kind of thing, when you're accessing the index where the value is the length of the array, then you know you're going to get an error. Lastly, for this one, well, 6% 2. Well, what does this percent mean? We didn't cover this, but this percent is a modulo operator, which means that it will find the remainder of these two numbers. So if we divide 6 by 2, we would get 3, but the remainder would be 0, right? So this expression would be 0 because that's the remainder when we divide 6 by 2. So what is the value at the third index? The 0th index, that's A, which means that this is going to return the string A. So I can, let me erase this. So we can talk a little bit about the mod operator or modulo. So if we did 7 mod 2, for example, if we divided 7 by 2, we would get 3.5 technically. But in Java, this would be 3 because in Java, these two are both known. These two are both have the variable type as integers, which means that our result will also have to be an integer, which means that it will actually truncate the decimal. It will remove the decimal. So even though in reality we would get 3.5 when we did division, our Java program would just truncate that and it would make the value 3. So in this case the answer would be 3. It wouldn't be 3, it would be different. But if we were doing division, if this was a division sign, then that would be 3. But however, we're doing modulo, which means that we need to find the remainder of what happens when we divide 7 by 2. In that case, it would be 1. So this would return 1. So it's how many times can you fit 2 into this number, into 7, evenly, and what would be the remainder when you've done that the maximum amount of times? So that's one way you could think about it.
So let me just get this straight. The percent sign is division?
The percent sign is modulo. This sign is division. It's a /.
Okay.
Yeah, you also have plus and minus, which you know about. And then you have the plus equals, which is for setting the value of whatever this variable is. So a plus equals 2, then that would just increase a by 2. And then you have minus equals, which would subtract that amount, and then set that equal to.
So to add or subtract, it has to be how many equals at the end, at the end of the sign that you're using?
To set it equal to that value, you would need equals. But to add or subtract, you would.
And is that for the same for multiplying? I think multiplying.
Yeah, you have multiply
is star.
Yeah, you have the star like that, and then you have the divide equals like that.
Okay, so everything that needs to be equal sign. Okay, just asking.
So if you're using the equal sign, it's just gonna set that equal to that value. All right. Let's go on to the next slide. So we've covered some practice with arrays. We've covered what arrays are. We know how to use indices to find the value at certain points in the array. Now we'll cover loops and iteration. So this is kind of interesting. So what are loops? Well, loop, it's exactly what it sounds. We're looping an action. We're doing an action over and over again. Some good loop design, or rather steps for loops. So first we will use a variable to keep track of how many times we have looped, right? We want to know how many times we are performing an action so we don't overdo it. So we'll keep a variable to keep track of that. First we initialize some variable. We can call it x or y. In loops, generally it's I, the variable, the letter I itself. I don't know why, but maybe it can stand for incrementation, which means increasing. But anyways, we generally use I, but you can use whatever you want. You can use Fred, for example, but we'll see that later. Then after we initialize the variable, we will generally perform the action, what we're doing. And I say generally because there's sometimes in some loops that won't be the case, but we'll generally perform whatever that action is. Then we will increment the variable, which means that we will increase the value of the variable by 1 because we have performed that action one more time than we did before, right? Before it was 0, but now it's 1 because we performed the action. Then we check whether the loop has executed enough times. So we will usually have a condition saying, have you executed this loop 10 times? Or is this variable greater than 10? If it is, then stop executing the loop. Otherwise, if not, then we go back to the step C, which is to perform the action, and then we will increment once more and then check. And then that will be a repeating process that we will use. What is this useful for? This is useful for automating like tasks that you want to have repeated and not having to do everything over and over again. And you can see how this might be related to arrays, right? Because when we have arrays, we have a bunch of different values that we don't necessarily know like a variable for. We don't have like access to it. I mean, we have access to it, but we don't have like a variable for every single one of them. So loops will be a great way to change every single value at once in one step, like in less code than if you wanted to change every single value manually. Like, say for example, if you wanted to add the letter B to all of these, so we know how we can access and set values of arrays by using this bracket notation, right? So you could say letters and then index of 0. The index at 0 of letters would be plus equals the string B, right? So let me actually write that. So letters, let's just say let 0 plus equals B. And then letters index 1 plus equals B. And this would get very, very repetitive and long, so that's why we use loops, because that makes that task so much easier. Alright, so we covered that. So let's do some examples of loops. If we have this statement that says count by 5 starting from 5 to 25, we know that's 5, 10, 15, 20, 25 right there. So what is the initialization? Well, we start from 5, right? So we would initialize some variable to say like, hey, x equals 5 because we start from 5. So let's actually write that down. I don't know why this isn't let me do literally the thing. So alright, so let's say x equals 5. That's our initialization. Then what is our action? Our action is to increase, or it's rather to print out our number, right? Because we want to count. So we'll print 5, or we'll print x, whatever the value of the x is. And then the incrementation is to increase by 5 because we're counting by 5s. So we would say x plus equals 5. And then what is the check? We can see that it's a condition here, but since we're stopping at 25, we would have to say x is less than 30. Now, why is it 30? Why is it not 25? Because if we said x, actually no, it would be 25. So, wait, no, sorry, it would be 30. I don't know why I'm making this mistake. It would be 30 because when we get to 25, we're going to say, is that less than 30? It is. So we would go back to this statement, and then we would print 25, and then we would increment 5, and that would be 30, right? Is 30 less than 30? No, 30 is equal to 30, so we would stop there. Or you could say x is less than or equal to, x is less than or equal to 25, like that. And that would be the same. Because once you got to 30, 30 would no longer be less than or equal to 25 because it's greater than. So it would stop there, and that would be the finishing like condition for our loop. So let's go to like the actual syntax. So if we have multiple different kinds of loops, we have while loops, we have other different kinds of loops that we'll cover. So while loops are the first one. So while some condition is true, like while x is less than 30, we want to have our statement. We want to print x first. We want to print x, and then we will increase x by 5. So the way that we could write this is by saying, let me delete this. So while x is less than 30, you would read that like how you do in real life. So while x is less than 30, what is our statement? Our statement, well, we said we print x because that's our action that we're performing, and then our incrementation is x plus equals 5, and then we close. But wait, I forgot one thing. Does anyone know what that is? Like, you can put it in the chat if you don't know what that is, or if you know what it is. Oh, not the semicolon. This is pseudocode. So that means that it's not like actual code, because I didn't put like the system.out.print stuff. I just said print. But technically you're right. It would be the semicolon here. But that's not what I was looking for. Like if I go back to this, do you see all of these steps in here? Do you see the initialization? Do you see the action? Do you see the incrementation? And do you see the check? Well, if no one knows, we can go through it. Well, we have the check because the check is right here. We're checking to make sure that x is less than 30 each time the loop runs. Initialization, yeah, that's correct. Because I never initialized x, so the program's going to be like, what is x? And it's going to give me an error. So yeah, that's really important. Make sure you set your initial variable for while loops. So x equals 5, and then we check to make sure that x is less than 30 first off. Then we print that variable, and then we go here. We increment it, and then we'll check once more, and then we'll continue that process. So that's while loops. You would use while loops when you don't know how many times a loop would run. And we'll see other loops that will tell us like we know that we'll use when we know how many times a loop will run. But in the case of while loops, we use them when we don't know how many times a loop will run. So the next loop, okay, well let's do this example actually. That might be helpful. So we don't have the initialization, but just assume that it's initialized as some value. So we have this number. It says number is less than or equal to 10. And then we print number, and then number plus equals 2. So I think in this case, I think I was starting it from 0. So let me just add that. So num equals 0. So while number is less than 10, so is number less than 10? Yes, it is, because 0 is less than or equal to 10. Then we print the number. So we will print 0. And then we add a 2. So number will become 2. Because we have this equals right here, that means that we're setting the value of number equal to 2. So number equals 2. Now we go back to the check. Is 2 less than or equal to 10? Well, yes, it is. So we say 2 here, because we print it, and then we say we want to increment that by another 2, which means that this will be 4. Number will be 4, and then we check, is 4 less than or equal to 10? Yes, it is. So we print 4, and then we add 2 once more, and then that gives us 6. Is 6 less than or equal to 10? Yes, it is. So 6. And then we add 2 more, so that's 8. And then 10. Let me write 8. So 10, once we get to 10, we see that we need to check it once more. So is 10 less than or equal to 10? Yes, it is. So we say 10. That's our print, and then we increment it 2 more, so that's 12. Is 12 less than or equal to 10? No, it is, so we stop there, and then we'll continue on with whatever the code was here. So, yeah. That's the while loop. Now we can go on to the for loop. So for loops, a bit different. We say for, and then we'll have our initialization, we'll have the condition, then we'll have the incrementation. All of these 3 will be in the same line separated by these semicolons, and then we'll have our statement in the middle. So what does that look like in code? It looks like this. This looks a lot worse than the for loop in terms of like aesthetic or whatever, but it's really useful because it tells you how many times you want a loop to print or a loop to run, execute. So in this case, we start with some initialization, I equals 0. Then we have our check. Is I less than 5? Well, yes it is. Then we would go here and do our statement, perform our action. Then we would go here and perform our incrementation, and then we would go to the end of the loop, and then we would go back. And then we see, is I still less than 5? And then we would determine if it is. If it is, then it prints. Otherwise, it would not do that. But since it is, it will print it, and then it will go on to the incrementation, and then it will increment it like 4, and then it will check it once more, and then it will determine that. So let's trace this actually, because that was not a very good explanation. But we'll see how this loop actually runs. So I is first of all I is 0. So you can say the value of I is 0. And then we need to check, is I less than 5? So, wait, actually let me make a table, because this is what you actually will do in the class at Monte Vista if you're taking the Java class. So you'll say something like I right here, because that's your variable, and then you'll say check, like that. So that's your check column. And then you write whatever values you're checking. So first I is 0, right? Let me write that down. And then you check, is 0 less than 5? Well, that it is true, so 0 less than 5, and then true like that. So T for true. And then that means you will print it out. So your output is going to be like somewhere here. Output, like that. That's a different column. So then you print out 0. And then you print out 1 actually, because we have I plus 1, so that's going to evaluate to 0 plus 1, which means it's 1. So 1. Right, and then we go on to the incrementation. I plus equals 2. Now I is 0, remember, so it will be 2, and then you can write that in the table. So 2 is 2 less than 5? True. So then we would print 3, because remember we have I plus 1. And then I'm pretty sure you got the process by now. This 2 would be a 4 after the next incrementation. 4 is less than 5. True, meaning we print 5 because I plus 1. And then we make it 6. Is 6 less than 5? Well, no it's not, so that's false. So at this point you can stop, and we have our output right here. So that is our for loop. That is the case for a for loop. Now we can move on to the do while loops. Do while is named do while because we have 2 keywords rather than 1. So we have do something while we're checking this condition. So we have our statement and our incrementation in these curly brackets, and then we have a condition in our parentheses as before. And I put this note here because it's pretty important. Do while loops will always run at least once, And you can remember this because we always have the statement and incrementation before we have our condition. Remember, we had our condition before we had our statement in the for loop and in the while loop, which means that we'll have to be checking those before we run the loop. But in this case, since we have the statement before the condition, we know that we'll have to run this first, which means that the statement and incrementation will run first in this case. So let's trace this one. Third example, int num equals 2. So let me just delete this. Alright, so we have our number variable, and then we have, what else do we have? We have our check right here, and then we have our output. So I would make like 3 columns for that. Check, and then output. I'll just call it OP for now. So our number first is 2. And then first, what we do is we print it out, right? So our output would be 2 first. And then we add 3 to it, so number becomes 5. Is 5 less than or equal to 10? Yes, it is. So let's write that. 5 less than or equal to 10. Like, remember, make sure you get the condition correct, because that's something that might be checked for on the actual like tests and stuff, so that's important. So 5 is less than 10, which is true, so we make number 5. 5, then we output it, and then we make it 8. And then 8 is less than or equal to 10, which is true. And then we write 8 here. I don't know why I wrote it before. It should be written after. There's not going to be a test for this class, but there will definitely be a test if you take the class at school. Alright, so now our number is 8. We print that out, and then we increment it by 3, so that becomes 11. 11 is not less than 10. This is false now, which means that our loop is done. Alright, so yeah, the test, so I was specifically talking about Monte Vista High School. If you're taking like the Java class there, I don't know about middle school, but in high school you'll definitely have that. So here, I just put this at the end for like a summary. So when we loop through an array, we are traversing it. Tracing is always helpful. Tracing is what we were doing right here. This is the table that we make when we're tracing. This is always helpful to do. And then when you start out programming and making loops, it's a good idea to output each value in your code to trace your program. Alright, let's move on onto the type along. So we will be doing this type along a little bit differently. Now that we have like a few basic tools in your like skill set, you guys can like write the code for this on yourselves for like some time, and then I'll come back and we can check it afterwards. And yeah, we can do the type along after that. So let's see what it's asking. So write a banking class that will store 100 transactions in a double array field variable. Initially, there will be no transactions, and the user will have to manually add them with the method we will write. For one method, allow the user to print their transactions. And for another method, allow them to add new transactions. Hint, use another field variable to keep track of how many transactions are currently in the array. If the array is full, let the user know. So give this a try. I'll be back in like 5 minutes, and then at that point we will check the answer. So I'll write the program with you guys after that. But be sure to give it a try first, because that will be more helpful than me like typing it first. So you can just call it bankaccount.java, because this class, it will simulate a banking account. And then this variable, this double variable, it will store the user's transactions, and it will store 100 transactions at max. So yeah, I'll leave this on the screen, and I'll come back in 5 minutes. Alright, hopefully you guys had enough time to try that on your own. Let me know how it was in the chat. Like, was it difficult or was it easy? So that I know, like, if I should make the program shorter. In the meantime, though, I'll share my screen for the new type along. So let me do that real quick. Alright, so you will have their type along folder like this, right? So let's see. Let's make the fourth folder for our fourth class. So now we can make our bank account.java file. So let me copy paste the problem so we still have it. So it says store 100 transactions in a double array field variable, and then for one method allow the user to print their transactions, and then add new transactions in another method. Alright, so remember, we always start off with our class heading, so public bank account.java. I mean, there's no Java there. So public class bank account. There we go. Now we need to first define this field variable, right? So we can say private double field variable like this. I mean, array field variable like that. And then we can just call it transactions. Alright, and then we will have a constructor like this. So public bank account. Now remember, we didn't cover classes and methods specifically, but I think we'll be doing that like next class or the one right after. But when we have constructors, that is the initial state of your object. Like whenever you make an object, this will be the first method that is called. This is what happens when you say like string a equals new string. This new thing right here is calling this constructor. Alright, so in this constructor, we will store the initial state of our bank account. And here it says that initially there will be no transactions, but it will store 100 elements. So we can say transactions equals new double array, and then we put 100 because we have 100 elements. So there's that. Now it says for one method, allow the user to print their transactions. So we can say public void because we are creating a method that does not return anything. Public void print transactions. And then inside we will use a loop. So to traverse an array, what we can say is for int I equals 0. This is our initialization. We start from the first element in this transactions array. Then we say I is less than some value. What is our check though? I mean, what is the value of our check? Well, we want to print all of the transactions, right? Which means that this will be less than 100. And then we will say I++, because this is our incrementation. You can also say I plus equals 1 because that's what we have been learning, but this is like more concisely written as I++, and then you would have your block of code right here. One more way you can do this is by saying transactions.length, because we know that this will return 100 because that's the length of this variable. Now we will print the transaction, print our current transaction that we're looking at. So we can just say transactions, and then we would access it at index of I, because that is what our incrementer is doing, right? We are using the incrementer to loop through this array by by first initializing it to 0 and then having the incrementer access all the values from 0 to 99. So we'll get 0, 1, 2, 3, 4, 5, 6, 7, 8, all the way until 99 for each execution of this loop. Which means that this is going to be like a substitution for that, because it's a variable. So we want to access it at this index I. So that is our print method. That is the entire print method for this instruction. Now it says for another method, allow them to add new transactions. Hint, use another field variable to keep track of how many transactions are currently in the array. If the array is full, let the user know. So we can say private int number of transactions. So this will represent how many transactions that we have currently added into our array. Initially, this should be 0 because we have no transactions in the array. So we'll set that to 0 inside of the bank account constructor. And then we'll make a new method. We can call it public void add transaction. But we need to, whoever is going to be using this method needs to be able to add like some value for the transaction, right? So we need to pass in some information from the outside world of whoever is using this method. That sounds like we should use a parameter. So we can say double amount, like that, and then that will allow us to add this amount into this array. So we'll have some array that looks like this, like these underscores are just values, but these values will represent each individual transaction. It will just be a number for whatever is being added. That'll be stored by this amount. First, we have to check if the number of transactions is less than the number 100, because we can have a maximum of 100 transactions, right? So if we were adding 9, like, I don't know, let's say we had $9, we wanted to add it, but all of these values were full. Like this is our transactions array and all of these values were full, then we shouldn't allow the user to do that, because that would result in an error. Because remember, we cannot change the size of this array. So that number of transactions should be less than 100 in order for us to add a transaction. So then we can say transactions index of number of transactions would be equal to amount. Well, what are we saying here? We're saying that we want the index at this value to be set to this amount. Why are we using number of transactions? Because think about it. Let's say we have 1, 2, 3. We would have 3 transactions at this point, right? But then that means our third index is still available for a transaction. So remember, the indexes work like 0, 1, 2, 3. So our number of transactions will always be the index that is available. So then we can say we set it equal to the amount, and then we can increment number of transactions, because now this value will be full. Let's say we added 4, and then number of transactions would be 4 in that case. Otherwise, we would print, we would tell the user that the transactions, or you cannot add any more transactions. And then I think that's pretty much it. So that is the program for bank account. Since we didn't cover methods and constructors and things like that in detail, like I don't expect you to fully understand all of that, but just know what these parts are doing. These are the most important parts that you should know for this lesson, at least until this point. So I think, yeah, we went a little bit over time, but if you don't have any other questions, I think you don't need to stay around for any longer because we've covered all the content for this. So see you all next class if you will join, if you'll be able to join for that. So yeah, that's pretty much it. I'll answer questions in the chat for like a few minutes until 3:10, but at that point I'll be needing to go. So is it less than or equal to? It will be oh, you mean for this? So while we're printing the transactions, well, let's think about it. So let's say we had this many values, which means our number of transactions would be 2. That means that if we start at the index 0 and we're saying wait, actually I think this might be wrong. I think what we could do instead is say number of transactions here. Yeah, that shouldn't be transactions.length, that should be number of transactions, because we don't need to print these missing values, we only need to print whatever is here at the moment. So yeah, I'll send out that in the email, like that was an error, but yeah, you should change that if you didn't change it. But let's see whether it's less than or equal to. So if we start at 0, we start at this value 1, and then we loop until we are less than the number of transactions. In this case it's 2, so our index will start at 0, which means we'll print the first value, which is the 0th index, which is 1, and then we'll print 2, and at this point the I value is 1, so 1 is less than 2, which means we print 2 because that's the value right here, and then we increment I, so I will become 2. Now if it was less than, this wouldn't run because 2 is not less than 2. 2 is equal to 2. But if it was less than or equal to, then this would run. So let's see what happens when we try to access the index 2 while our number of transactions is still 2. That means that we would be accessing this value, and in this case this value is a missing value, which means that we would be printing a missing value, and in that case we would need to use less than because we don't want to print any missing values. And I think when you try to access values like that, you might get an error. So yeah, I would just say use less than to be safe. Yeah. Alright, so is there any other question? Yeah, we would have a missing value because it hasn't been defined. That's correct. Alright, bye. Alright, I'll stop the recording now.